The final part that's new, and it's somewhat new, is natural logarithms. That's what we're going to be talking about today. You guys remember that constant e that we talked about with continuous function, or like continuously compounded functions?
Yep.
So we're bringing that back today. We have this equation y equals e to the x powered. What kind of equation is that? Exponential, because it has an exponent. So I'm just going to write expo for exponential equation. You don't have to write this, sorry. We're going to just write what's down here in black. This is an exponential equation. Inverses of exponential functions are, what's the inverse? Logarithmic functions. I'm just going to write log. The inverse of e, they're called natural logarithms. That's what we're going to be using to simplify equations that involve e, or natural logarithms. Now they look kind of weird, but the way that you write them, extend this here, is ln. And then this little line here, that's just the natural log of whatever number you're taking. So you'd think it would be NL for natural logs, but it's ln. What this means, it's a natural log and it's base with base e. So just like, what's the regular base for a log function? 10. So in this case, the invisible base is going to be e. The properties, same as regular log. Think back to what we've been talking about. If I told you log of 10, what would that answer be? 1, because the base here is 10, so it's saying 10 to what power gives us 10? 10 to the first power. That's why it equals 1. So think about this. What do you think the natural log of e is going to equal?
1.
Also 1, because the base is e. Same idea. So this is what you want to keep in mind. We're going to use this a lot today. The natural log of e is equal to 1. Any questions so far? Just as the property states, everything is going to be the same for natural logs as it was before. If you look at this graph here, you'll see they're extremely similar. It's just that we have a different base. The asymptote still exists. It's never going to reach 0. Natural log is still a log, so the same rules apply. We want to write each expression as a single natural logarithm. This first problem, natural log of 7 plus 2 times the natural log of 5. Think back to when we were combining regular log functions. What can we do here? Multiply, but first we need to
change it to exponential or whatever form.
We need to write this 2 that's out front. What can we do with that?
Oh, make it exponential.
Put it in the exponent. So it's going to be the natural log of 7 plus the natural log of 5 squared. Now, like Michaela said, multiply them because it's a plus in between. Same idea applies. So it's going to be the natural log of 7 times 5 squared. Punch that in your calculator and tell me what you get. What did you say, Kim?
175.
175. Can't take that any further, so that's our final answer right there. Because our rules with logs, if you're adding in between, you just multiply the numbers together, or the variables. So in this case, Nope. So it's just 7 times 5 squared is 25. So 7 times 25.
Wait, I still understand.
So what's 5 squared?
25.
Take 7 times 5, 25. And then you get 175. It's fine. Over here, 3 ln of x minus 2 ln of 2x.
ln x cubed.
So it's the natural log x to the 3rd power minus the natural log.
2x squared.
So be careful on this. We're squaring both parts. A lot of people would get this wrong. Because that squared, it's affecting the 2 and the x. So it's going to be the natural log x to the 3rd minus the natural log of 4x squared. And since it's the opposite of addition, which was multiplication, division. So this is going to look like one big fraction. X to the 3rd over 4x squared. That's a 2. What has more x's, top or the bottom?
The bottom.
Top. So how many are we going to be left with in the end?
1.
1 on the top. So it's going to be the natural log of x over 4. Any questions on that problem? Like I said, it's the exact same idea as we were doing with the regular logs.
So that's just the half of the natural log.
Yep, because our goal is just to combine them. Well, let's skip this one. Go on to this one right here. Again, all numbers up front. Let's just put those into the exponent. Angelica, how's this going to look?
No. But would this be one of those problems where you move the 20 to the x?
Yeah, exactly.
So you move the 20 to the x and it's x to the 20 power, and then the 5 would go to the y.
Yep.
And then 2 would go to z.
Exactly.
Is it Wednesday?
Yeah.
Tornado. It's not every Wednesday. It's the first Wednesday.
Now we need to do what? We can do this all in one step, actually.
Positive on top.
Put the positives on top and the negatives on the bottom. It's just going to be one big fraction. So it's going to be the natural log of this one's positive times y to the 5th divided by our negative, which is z squared. Can't reduce anything there, so that's the final answer.
Oh, wow.
See how we took the plus, so that's what ended up multiplying? And then the z squared was a minus, so we divided. I wonder if they'll hear that noise on here.
That's funny. They have to do it for a certain amount of time.
Is it Wednesday?
Now we're just going to solve natural log equations. So the natural log of x is equal to 2. Let's think back to how we were solving these yesterday. What's the base of a natural log?
And e.
So can't we just use that same trick we learned yesterday?
Yeah.
So E is the base.
Exactly. So we're just going to put e as the base for both parts. What happens to e to the ln?
They cross.
They cross off because the base is the same. So we're just left with x equals
E to the same part.
e to the 2nd. Plug that in your calculator. What do you get? Because don't forget, e is a constant. It's a number. Let's go to the 3 decimal places. 3, 8, 9.
I have a quick question.
Sure.
What's the number for E again? How do you get that? Isn't it?
It's like 2.71.
It automatically gives you
Yeah.
the number.
Oh, wait, what?
This one here, we have the natural log of 3x plus 5 squared equal to 4.
Okay.
So
Wait, are we doing B or C? Wait.
We're doing
What is
B.
okay.
We can do the same thing, right? Just take the base with E. So the only thing different than yesterday is rather than a 10 as our base, we're using E. That's all it is. So now this cancels off and we're left with 3x plus 5 squared equals e to the 4th. How do you undo a square? Square root. So we're left with 3x plus 5 equals, this one we have to be careful of. When you take the square root, you get two answers.
Plus or minus.
Plus or minus e squared.
Oh, E squared. Okay.
Well, let's solve it and see if a minus will work in the end. So separate this out into two equations now since we have the plus and minus. So it should be 3x plus 5 equals e squared, and 3x plus 5 equals a negative e squared. How do we get this x by itself?
Minus 5.
Minus 5 first. 3x equals e squared minus 5. I wouldn't plug this in your calculator yet. Then divide by 3. So what do you get for x in this equation?
Second.
5.7.
I don't think that's right. I think it ends up being less than 1.
796.
Yep. 0.796. So make sure you type in e squared
Oh.
minus 5, and then hit equal and divide by 3. Now, this one, it's not going to be the negative of it. We're going to get a weird answer on here. So subtract 5 first. Same process. So we get 3x equals a negative e squared minus 5. Now divide by 3. What do you get for this x? Negative 4.129. Now, as Kinnery mentioned earlier in this problem, if you plug in this negative here, is it going to be too big? Or like, it's going to be a negative inside parentheses? We don't want that. So this answer would actually give you an error if you typed it in. If you plugged in natural log of 3 times negative 4.129. So our only correct answer here is this one. All right? We're just going to skip the next two. It's the exact same process. Now we're going to go with the reverse pattern. We have e in our equation. We're going to have to use logarithms in order to solve these. Why would I want to use logarithms in order to solve an equation like this? Yeah, I'll enlarge it here. Can somebody tell me why I'd want to do that? Use logarithms? We want to use logarithms because what's the inverse of an exponential? So we need to use logs in order to undo these exponentials. If we have e to the x minus 2 equal to 12, are we able to get like a common base between e and 12? No, so we have to use logs. Which log do you think we're going to use? Natural log. So let's take the natural log of both sides. Now that we have a log, what can I do with the exponent? I can put it out front. So it's going to be x minus 2 times the natural log of e equals the natural log of 12. Think back to what I said to remember in the beginning. What is the natural log of e?
1.
It's just 1. Yeah. So that's just going to become 1. So all we have is this x minus 2 equals the natural log of 12. How do I get x by itself? Add 2. So our final answer is going to be, what do you get when you punch this in your calculator? Sounds 4 point what?
4.484.
Well, but it's
That sounds
485.
I got
large.
2.639.
That sounds.
4.484. I got 4.484.
Okay.
That's what I got.
Let's hold on for just 1 second. So type in the natural log of 12. Make sure you're not hitting the log of 12. It's got to be the natural log.
Yeah, I got 4.484.
And then you added 2?
Yeah,
4.48.
It's 4.484.
Okay.
You're 6.
Do you just press LN and 14?
It'd be 485 because that 4 rounds up.
I have 2.6.
We are skipping B and C for those that didn't hear what I just said. So with D, let me just enlarge this here. With these, we should always try to isolate the part that we don't know how to solve. So what's the part we're concerned with? So how would I isolate that? Subtract 2. So we have 4e to the 2x equals 14. How do I get e to the 2x by itself? So e to the 2x equals what? 3.5, or 7/2, whichever one's going to work. Now we have it in the form so that it's similar to that first problem. So what do we need to do to undo this
Do
e?
the LN.
Do the natural log. Natural log of both sides, don't forget that. Then we can take our exponent, put it up front. So we have a 2x. What happens to this natural log b though?
It's just 1.
So it's just times
Just
1.
not really using.
Yeah. And then we're left with the natural log of 3.5.
And you just do that by 2.
Oh, that's not true. And then to get x by itself, all we have to do is divide by 2. So what do you get for your final answer?
0.626.
6?
0.626.
0.626.
There we go. Alright, any questions on that? So these work, they operate in the exact same way as the regular logs. The only thing that's different is we have base e now. Okay. We need to make a correction on this x equals 1.626. It's supposed to be, what's our answer?
0.626.
Wow.
That was so how we said that.
There we go.
Right.
Now we're done.